Welcome back to another episode of DevTalks, where we talk about everything that has to do with engineering and technology. Such a great world that we live in today with your host, Travian. And man, we're here for another episode. So, quick updates and news. I believe Thursdays now are going to be the release days for episodes. Uh, just want to try something new and test it out and see how that works around my scheduling and stuff versus Tuesday. So, we'll see how that goes for a few weeks and hopefully it does better and good. But today's episode is great. You're going to learn a lot in this episode. I've learned a lot in this episode. And as I said many times, I do this to learn more. So I did an interview with one of my good friends, Brennan. He's been on the podcast before. So I don't want to get too much into it, but we're going to pretty much dive right in. So let's get in. Welcome back to another episode. Like I said in the intro, I have a good friend and he's not new. Is Brennan. He's back, so welcome back.
Hello, hello. Thank you for having me.
Yeah, no problem. Always, it's a pleasure. It feels like I have you here all the time because of something that goes on for our jobs or something that's related to our working. So
Mm-hmm.
you actually did something regarding and writing an article, and it kind of fits in the engineering world. And me personally, I've been thinking about what engineering and technology is more on a broader spectrum recently, so that I can come up with more things to talk about and things in that kind of nature. So basically, if you just want to introduce yourself again and like what you do, just in case somebody new is listening, then feel free, and then we can dive right into what this article and stuff was about.
Yeah, absolutely. Yeah, my name is Brennan. So I am a software engineer. Or I guess technically I guess a data engineer really. But this article that I wrote was when I was a Capital One tech intern at the time. Now I currently work for Capital One as a TDP. Very fun. Been working there for like 5 months. But yeah, now I'm basically on like a data engineering team, and it's been great so far.
Yeah, that's good. That's good. You actually stole one of my questions. I was going to ask you what the article was about and everything,
Yo,
but
yeah, I can definitely
yeah.
go into it. Yeah, sure.
So if you, yeah, so just to get us started and everything, what would you say the article like? Just give us some details about what it was about, and then we can kind of pick at it a little bit more.
Yeah, absolutely. Yeah. So, my intern project, as just like a very, very light overview, is that I was working with these things called vector databases, um, which is not the same as just a normal like relational database. So, here's a question for you, actually. When you're thinking of like a normal like database, like how are you kind of picturing that? That's the real question.
So for me personally,
Hmm.
it's a database that has tables and rows with that have different columns and
Uh-huh.
listings that have different kinds of data in them, and they have different data types, whether it's like strings or integers and dates and all them different kind of stuff. Because
Hmm.
stuff that I do in work, it works around a lot of SQL things, so that's kind of the database that I think of, regardless if it's like RDS one, which is a kind of relational database, and other kinds in like BigQuery and AWS. It really depends on what I'm using, but that's what comes to my mind for it.
Yeah, no, that's exactly like what I'm looking for. Yeah, because that's what people are normally thinking of when they think of a database, like something that's just like basically just looks like a CSV almost. You know what I mean? Like all these
Yeah.
just normal columns, normal rows, like intelligible data types, right? Well, I guess in this case we call them like simple data types, right? So like numbers, like int, float, booleans, even just like characters and strings, right? Or like date time, whatever. Like pretty similar stuff, right? And
Yeah.
it's like if I have like tables like that, right? Um, very good for asking questions like I don't know, like let's say we have like a bunch of patient data. I'm biased as the med background coming out, but like I want all these people. I want to like do this analysis on like all these people who are like above, I don't know, like 18 and above, you know what I mean? So, I mean, that's a simple like that's a pretty simple SQL statement, right? You just look for whatever like the age column is and just kind of like you do whatever, right?
Yeah.
Cut and dry. But
Yeah.
how about a question like this, right? Um, how about I have like a column, right? Which what we'll just have like pretty like simple like text data, right?
Yeah.
Um, that's like I don't know, something simple like movie names or something like that, right? Um, you could have like search up all the movies with like Indiana Jones in it. Like that's just like just a simple like substring search.
Yeah. Yeah.
But what happens if I'm like if I want to have a business question like give me all of the movie names that are similar to Indiana Jones?
Okay, you can see how that can be a lot harder to find,
Yeah,
like
yeah,
from a
because it's like
query at
how
least.
yeah, because how do you do that? Do you just have to like arbitrarily like pick like a bunch of like substrings that I guess in your opinion are like similar to Indiana Jones or something like that, right?
Yeah. Yeah. Yeah.
Yeah, it's kind of like a strange like idea, right? Um, and that's one of the things that um vector databases can be very good at figuring out because instead of just having it be as like this just row column kind of stuff, we store this data. We store like data points. And I want you to think of them as like data points and like XY like
Okay.
kind of like
Okay.
graph. I want you to think of it like that. We store them as data points. And the thing is that we associate something called an embedding with it. Now, what is an embedding, right? And an embedding is think of it in this case as it's just like a vector of numbers. So or that is what it is, right? Because
Yeah.
it's
Yeah.
like to be very simple, right? Like for example, unless an XY graph, right? Your vector is just like it's two dimensions, right? So you could be the vectors like one and two. You know what I mean?
Yeah.
Something like that. So how about we have all these movie names, right? Kind of being placed on this graph, right? So let's
Okay.
say I have like I don't know, Die Hard, Taken 2, Fast and Furious, like, something like
Yeah.
that.
Yeah. Yeah.
Yeah, we're gonna put them all in like, like the upper left quadrant or something. That's arbitrarily, right? And
Okay.
then I don't know what's different. The Barbie movie, right?
Yeah.
Um,
Yeah.
we're gonna put that like way over to like the bottom right or something like that, right? So if I have like Indiana Jones as like my query, where would I kind of want that to end up if like these are like this is like my spectrum, huh?
um, Definitely between them, but closer towards the top left, I would say,
Yes.
with more action
Yes.
and stuff.
Yeah, exactly. So and that's kind of like what we're trying to do here, right? We're trying to do like this similarity search based on distance, right?
Yep.
We we want these similar things to be close to each other so we can kind of relate to them. This is something we call like similarity search or like similarity search for like recommendation systems. You actually might remember that from data mining. Well,
Yeah, a
like
little
we
bit. Yeah, I
very
do remember
very
that.
briefly.
Yeah, that is actually kind of familiar sounding now that you bring it up. Such a wonderful class.
I know, yeah, for reference, we took the same data mining class in UD, kind of hilarious. Yeah, so and that was the funny thing. I took that class after I did this project, so I thought that was really really funny. And so yeah, back to the point, it's like
Yeah.
we have we want this database to be able to do something where it can do like this similarity search that's basically like on this this dimensional space, right? Just keep thinking of it as like 2D space though, because it's easier to think of that than like 5 trillion. But um yeah, it's pretty clear, right? That it's like
Yeah, that
doing
clears it
something
up.
like that, yeah, doing something like that in like a normal relational database is pretty hard.
Yeah,
That's
that
pretty
that
tough to
would
do.
be very hard to do.
And so I guess one of the next like leading question is how do we get these embeddings, right? How do we get these? How would you even like begin to like think about how to just to assign these data points, these dimensional points to these to our like documents? How do you think we could get that? I don't expect like a crazy answer, but just give me a
So,
guess.
yeah, as in how would you assign one of these points to what kind of document? Like, is it
so so
CSV or
so
something?
so I mean as in like so let's say you know like for example like in our example like taken right
Yeah, yeah, yeah.
as like I said like, it's in the upper left quadrant. But
Yes.
how did I assign it that coordinate? You know what I mean?
I guess it would depend on a bunch of different variables on like the type of movie that it is and like what goes on in it. I would say that's how I kind of moved it, like especially for the Indiana Jones stuff, because you have Barbie, which is like a certain type of movies go based off genres and things like that, basically.
Mm-hmm.
So I would assume genre would help move it to like the left or right or something, and then up and down depends on like some other possibilities or genres maybe, or whatever way you're scaling that particular thing in a
Yes.
database by.
Yes, I like this. I like where you're going with that, right? So we can have like the X and Y axes. They represent something meaningful, right? So
Yeah.
it's like if that was like like maybe the X was genre and like the Y was like I don't know, age rating. It means like something like
Yeah.
it's some feature, right? Related to the related to the movies themselves, right? It could be anything. Could even be like the length of the string for like for all we know, right?
Yeah,
Um,
yeah.
but it's a feature. You know what takes features?
Vector databases.
No,
Or
something else. Uh,
oh,
ML models,
I,
machine learning models is generally how we can get these these embeddings associated with them.
okay, okay. It's
So we aren't manually. I'm not manually saying, yeah, take it in two belongs at like coordinate 0, 1. I'm not doing that.
so basically, if these models put Barbie at the bottom of the graph, it just means it thinks Barbie sucks.
Well,
So,
in a way, we don't even really know what it's like trying to say. It's just saying that it belongs there.
yeah, yeah, yeah.
So that's the thing, actually. What we're doing, um, is that, and this is in our article. So, what we did, was that our vector database, um, we would have like text data, um, and actually, I I think in my article I actually used like a Kaggle data set of like hotel ratings,
Yeah.
which is very funny. Um, but point is that we are feeding this into a neural network actually, which was what one of the other interns was working with. I was working closely with them. They're very smart. But they were using something called a character convolutional neural network, or a char CNN,
Mm-hmm.
and these neural networks, they're like composed of like many different layers of like transformations. Okay, it's it's really like a black box. It's like we are. That's kind of what I mean. Where it's like we don't necessarily know like why maybe Barbie was put in like the bottom right,
Yeah,
but
yeah,
it is getting put there. And similar things
yeah.
are getting like are getting associated with each other. The model is taking care of that for us. Um, and the thing is, normally, with these like models, right? You're going to be looking. It's going to be trying to make some prediction, right? Maybe, of like, oh, like this. Maybe this model. I mean, maybe this movie is like good or bad, or like for like younger audiences or older audiences, like some
Yeah,
kind of
yeah.
thing. But that isn't necessarily what we're using the model for. Like the model can be making those predictions, but what we want is that we want a different slice of the cake. You can think of the model as a cake of different layers, but what I want is one of the intermediate layers. And in one of those layers, um, we have what the model is representing. Sorry, actually, let me say that again. We have a vector embedding representation of the text. So what the hell does that mean? I'm saying that if I have Indiana Jones put into the model, at some point in the model, it's going to be transforming that information into just a one-dimensional vector of like so Indiana Jones will be represented by like like 1, 2, 5, 17, 6, 8, like
Yeah.
some number nonsense, right? Um, and that is our embedding, and that is our coordinates basically that we're putting on the graph. you know,
Yeah.
in our example, we're thinking of things like 0, 1, 1, 2, whatever. But like in like for example, my article, like our example is like doing it for the vector of like 1024. Like, it's something that's like
Yeah.
hard to even like imagine.
Yeah, yeah.
Right? And but we use that. We use that to place our documents. So I'm going to be referring to these data points as documents because that's actually like the terminology. But
Yeah, that makes sense. It makes sense.
yeah, yeah. So they're taking this space up like these documents like in this vector space, and from there we can we can actually just calculate the distance of a query point. So, for example, Indiana Jones, we take its vector embedding, like you run through the model, take its vector embedding, um, kind of like position it the in the database, and then we look at what are the closest points to Indiana Jones in this point, right?
Okay.
And that's how we can get like recommendations, right? Like that's how you get recommendations for like, oh, if you like Indiana Jones, here are some similar movies. That is similarity search.
Okay, so two things. One, I
Yes.
feel like you explained similarity searching in vector databases at a way better level than any of the college professors. Uh, as starters. So now, if anybody wants to know about that, I guess they just need to listen to this 20-minute clip and be like, here you go. and, and you got it. Uh, but yeah, it's actually crazy that the second thing is crazy that you were talking about using the ML models and things because that's something that I actually have to pick up on
Hmm.
now, just and figure that out. So that is actually interesting. That's part of the things that go along with machine learning. That's of course my job working with the databases that we work with, which are not the like vector ones, of course. We do work a little bit differently and stuff. So I always mess with that data differently, and we
Hmm.
work around it very differently. But when I'm up to speed on how we're using the ML stuff, then I wonder how it's going to compare to this. So it's
Oh,
actually very
believe me,
interesting.
there is like so much of this that I have not even like that I don't even like know myself. Like quite frankly, I can certainly speak on the parts that I worked on, but like
Yeah.
the there are like many like use cases like for using this. Um, to be honest, like because it's not just text actually. Um, it it's good for representing just complex data types in general, right? So like,
Okay.
what do they call it in a relational database? Even like a complex data type, it's a blob, right? I think. Yeah, it's something
No,
like that.
that sounds very familiar. You about to have me just Google it,
Yeah,
honestly.
yeah, like things that are like not clearly like very like primitive data types, right? Or
Yeah.
like strings and stuff. I'm pretty sure they're called blobs, but it's like like real files, right?
Yeah.
Like
Yeah.
audio, right? Or like images, right? You know what I mean?
Yeah.
Like we can use um we can use these embeddings to represent, quite frankly, anything. So you could think of it as in like even if I wanted to recommend like a song, right? As long as I have like these vector representations of of the original like object, then you know anything's fair game. And that's what's like really crazy about it. Because all you need to do is just do the pre-processing to feed it into a model.
Yeah. So that's yeah. Well, you're right about the blob thing, because blob the blob is like, of course, it's a binary large object, but it says it
That's
refers
it.
to a set of binary data saved into a single entity. And examples, of course, are images, videos, spreadsheets, PDFs, other files, all that kind of fun stuff. So
Yeah, yeah. See, there we go. Yeah, exactly.
this is what happens when you don't have to worry about the data procurement and stuff like that for work. You just don't know all the terminologies of stuff. It's actually funny because even like how long I've been working as an engineer for almost 2 years, there's so many like terms and everything else that you do not know yet, and like you're trying to learn and things like that. It's actually quite scary, but hey, it's
Yeah, that's just that's the spooky thing. About just like being on the jobs that you're always learning. I remember like I remember this actually the vector database stuff was actually like really frustrating to me in the beginning just because I was I couldn't handle the fact that I did not know what the heck was happening within the neural network. That's the black box. You know
yeah.
what I mean?
That's
I'm just
not
like, oh, it's like okay, I guess I have my embedding.
yeah. That's why you just sit there and just ask a bunch of questions all the time. Just be like, hey, stupid question, and just let it out. I do that twice a week, possibly. Yeah. Hey, but it's a lot. So before we dive a little bit deeper and stuff, how did they give you like the opportunity to write an article on this? Is this something that like all interns do, or
Certainly not.
okay.
Certainly not. I had I had the lucky I had the lucky draw of having this team who, in the words of my previous manager, was I run my team like a research team. And I was like, oh, that's interesting. And yeah, we kind of just we work on these exploratory projects in my team. So
Okay.
there was actually like many um like a few different like opportunities that I could have worked on. I won't talk on all of them because not all of them are have like a public article related to them
Yeah.
yet. yet. Oh, I can talk about the I can talk about the other one though because it was the
Uh,
character CNN.
what were the
Um,
other options for
the only
articles?
two I can talk about, the only two I can really talk about is like the mine, which is a vector database,
Uh-huh.
and the character CNN work, which was really quite cool. And so the character CNN is how you're taking in that text data and making it like readable by the model. I said that wrong. I said that a little bit wrong. The character CNN is doing the processing. That's how what we're getting the embedding from.
Okay.
But um, the process in which we did it was you have to do a little bit of processing of the text before you can just feed it into the character CNN. Um, the character CNN is quite interesting because it's like it is, I might butcher this, but but it is making is making decisions on the character level of the text you're feeding it. So you're feeding it like a passage of text, and then each character is getting converted into a number to be fed into the model,
Okay.
basically,
Okay.
is how it's working. So like for example, right? A oh man, what is the easy example? Like um cat, right? I guess. Um we initially start with this thing as like we have an alphabet associated, and our alphabet is just all the characters we expect to see within the text, okay?
Yeah.
Um and that would just be like a long string of like A, B, C, D, E, F, G, blah blah blah,
Yeah.
right?
Yeah. Yeah.
So if we have cat, then it gets pre-processed to become something like um 20. I don't know what T is gonna be, but
Whatever
like
number T is in the alphabet
yeah,
minus one.
yeah, because like
Yeah.
the one-to-one mapping, right, is that
Yeah.
A is 0, B is 1, C
Yeah.
is 2, but it can be whatever. Like it just depends on what your mapping is, right?
Yeah.
And that was a really interesting project, you know. I will if I at the time I will have worked on both, quite frankly. Well,
He said I would have got two articles instead of one.
yeah, shoot, like, really interesting stuff. The I chose the vector database though because I did research, you know, in UD with like, and I was working with ML models, so I kind of wanted to pick the thing that was immediately different because I thought it would be the most um how do I say it? I would gain the most knowledge from doing that. That's how I would put
Okay.
it.
Okay. So,
And I kind of was looking for the most software engineering thing they could give me because I
yeah.
was honestly looking for something more software engineering at the time
Yeah.
because
That
I
makes
did so
sense.
much other like ML research and stuff like that at the time, so I thought it was funny.
Yeah, that makes sense and everything. What would you say? How did you feel when it came to actually writing the article itself and putting your portion in it?
I thought it was great. I had a blast doing it. It felt very natural, I would say.
Okay.
And I think the reasoning is because at the end of the day, these projects would be picked up again by like other people, like most likely in the future. I say it with an asterisk. I say most likely,
Yeah.
you know. Um and and we like knew ahead of time that like this would probably be associated with an article, like that was like the plan.
Yeah.
So I mean in general though, I am very heavy in documenting and commenting and having really like clean cut code on like what I'm doing.
Mm-hmm.
So when it finally came towards the end for me to just work on writing the article, I was just like, okay, well, I basically just wrote half of it already.
Because
oh,
you
oh,
documented it, so I guess so.
Yeah, exactly. And it's like like after that, like I just had to talk and like I just had to write in like a teaching voice, I suppose, which I'm
It's
used to.
yeah, I was gonna say it fits you very well. You know, that actually does fit you. That whole role, like the whole teaching and things. It's actually funny how you're talking about like writing the documentation because most likely somebody will come after you. I can't like say it enough to a point that it can ever be tired of saying it because documentation is like the most important thing when it comes to like engineering and like anything you develop as an engineer and people who come after you because a lot of new people, which I can say can, especially from some personal experience, if you have new engineers coming on a project or certain like procedures and things that you guys do on a team in a company, if you have no documentation, they feel way less comfortable because they have nothing to go off of, and then it feels like they personally are bugging you all the time. So
Amen.
like, and they nobody, and it saves you time. Like all the time that you spend writing the documentation, it will save you time in the future, and you're gonna make somebody's life way better. And
Amen.
I hope everybody really takes that in because that's something that's like really important that like I don't get enough. Even like for one of my reviews for work, I put in as a goal in there is to like increase the documented procedures that we have and stuff for a team and things like that. Like it's hard to measure it, but it's still like there because of how important it is. Like I truly feel it's very important. So document everything.
Absolutely. It is extremely important, and it is twice as important if you're doing exploratory work. Because
Yes.
again, that's what our like work kind of was, to be honest. And we even work with like open source stuff too to make it easier. I didn't really like mention this point yet, but it's like our our vector database of choice was something called Vespa. We used Vespa. It is open source. Um, and I think because of that, it has lots of like it had a lot of like documentation at the time that was just like publicly available, which was nice.
Okay.
Um, and just let us just like experiment without like having to um well, for one, like pay anything, frankly. But it was just had really good documentation, frankly, and it was nice to work with because of that.
Yeah.
And it's like if we didn't have that, I mean, like shoot.
Yeah, that's always the best, man, having that. Um so next, so recently you told us about this
Mm.
article and stuff. Was it out the whole time or did it just like once when it came out you finally told us? Like it took them more time to like go through.
Oh yeah, yeah, yeah. So this was it was done. I can't quite get into all of the details, but I
Yeah.
can say this that like it was done for a while. There was just like things to like figure out, like in terms of like
Yeah,
releasing it.
corporate
What?
stuff.
Yeah,
Yeah.
it was just corporate stuff, frankly. I mean, like, cause this was basically ready to go. Um, right when like when I left, like it be reviewed obviously like again, but it's just like it was done. Frankly, it was done.
So here you go, another prime example of corporate taking their sweet time on letting stuff free. What?
Oh,
But
tell me about it.
that like, but you kind of get it to a point. Like you want to make sure that when you review it, it doesn't have like stuff that's not supposed to be said in it and things.
Oh,
Like
absolutely.
on their
Yeah, I was
aspect.
afraid.
So they take I like you like some people may not understand corporations take that stuff so seriously. It's not even funny. Like if anything gets out, it costs them so much more money and stuff. So like that stuff is so serious. Like such a serious topic that you can't even like reach the top of it because you mess up one thing, you gone.
We, yeah, we were literally like having a conversation before we like popped open this podcast about we were trying to trying to talk
Yeah.
about like what we've been doing and just we're just like skirting around the actual like details
Yeah,
like what
yeah.
we're doing.
Yeah, we just catch up like every time me and Brennan catch up in things, like especially being at these companies, we always ask like kind of what are you working on, but not exactly to an extent. And like you always hear like the restraint on like us work around in our heads how to explain like what we're doing because some things are just can be talked about and some things can't. So that's just the world we live in. It's a fun world. It's exciting, but
Dude, that is precisely why dude I could not work in like the government. I swear to God. Like
oh my
if you
gosh, like our
if you
one
work in
teacher.
the
Oh,
go ahead, go ahead.
like like our one teacher that we had, the one that taught
Mm,
database, one of my favorite
yes.
classes, he
Mm,
in Java. So we had a teacher that worked in the government and job, and he always like took the train to DC and things like that.
ugh.
And he like told us what his position was, but we never got a drop of what he does at work. He only taught us he the only thing he would ever tell us is how important like certain like learning SQL is and like how important like this stuff is for your job. And like he would the only other thing he would do is because he interviews people, he would tell us this is a potential interview question and things. But besides what he did for work, nobody knew like what they're working on things. And like it's just what you have to live with to a point. Like it's so
I
broad.
could not do that because yeah, and that's a shame, right?
Yeah, it
Because it's
is.
like he he's a great teacher first of all, but I will say it's like it's a shame when he like you can like say that oh these things are so important, but you can't really like specifically back it up because you can't talk about what you're doing. That's why I'm so thankful they actually released like these articles because I'm like, oh, thank God I can actually talk about this stuff because I think it's cool.
Yeah. Well, um, back onto the article thing and
Yeah.
what you wrote about real quick. What? How would you say that what you were working on, like the topic in the
hmm
article, and like writing these articles? How would you say it's important to engineering in the engineering world?
Um. So okay. Oh, I actually like that question. So I I think the main value of my article is mostly just like personal education on the matter of like because my article is half theory, which is basically like everything I was talking about earlier.
Yeah.
It was is like in the article, save for some funny equations I put on there for like the actual calculations of like similarity search, but
Yeah.
because I'm a nerd. But yeah, but I have the theory behind like how this stuff works, and then all the nice pictures I made myself. And then I have a walkthrough of how to set up your own local Vespa database and just perform some um a similarity search using a free Kaggle dataset, which thank God Kaggle exists because that like it's just nice textual data for you to just like train and try some stuff on. Um, Now how what this is important for like the engineering world is that this will like the idea is like this just educates people who are like interested in the idea of vector database and it's their decision like from that point forward to like research more into it and like see how like can a vector database not that doesn't have to necessarily be Vespa. There are like
Yeah.
proprietary vector database like files like Pineco Pine cone, that's a Pokemon. Pine cone, pine cone, for example, to like leverage. But like at the end of the day, like the conceptually, like these vector databases are like all similar. Um,
Yeah.
and it's just on the engineer who has like tried to play around with the idea to like extrapolate that idea for like their work. So it's just a jump. It's meant to be like a jumping point. Or an entry point, that's probably a better term, into the space for people who are not necessarily like, ML the wizards, or something like
Yeah.
that. It's just people who are just, tangentially interested in the topic, and like now maybe this will become extremely useful to them. You know what I mean?
Okay.
So,
Okay.
so that is how I think the article is like is its main benefit, and I wrote it to be that way, kind of. It was really just written to be an educational piece as an introduction to the subject. Even
You're such a
actually
teacher.
I'm such, in the title, the title it's even titled Emerging Vector Databases, a Comprehensive Introduction. So
Yeah.
so if that's not like apparent, then I don't know what is.
Yeah. Yeah. You're such a teacher, man. Like when it comes to educating somebody, you definitely got it. Like
I appreciate
the
it.
well, here's a kicker for a follow-up question regarding what I just asked.
Sure.
How will you think that it will improve on technology in the future?
Yeah, so okay, so that's also, I guess, like part of the title. I did not actually put this part. They actually edited this part, which is hilarious. They wanted emerging vector databases on there, but for good reason. For good reason, by the way, because
Yeah.
it's like there's a reason we're discussing this. If we were discussing like relational databases, like who cares? I mean,
Yeah.
okay, someone cares. I should have said
There's a
that.
lot of people who use that, sir. They need that data. Come on now.
They need it, but in terms of like knowing what it is, there's a zillion things out
Okay.
there.
Yeah.
That, that
Yeah.
that's kind of what I that's kind of what I didn't mean to make it sound so hand wavy, but like it but yeah, for stuff like that, even like stuff like MongoDB, like, or just like NoSQL, like in general,
Yeah.
like stuff like that. There's stuff out there for it. It exists, right? And not to say there isn't things for vector databases in general, but there is certainly not that much, right?
Yes.
Um, and sorry, what was the question again? Sorry, I started rambling and I forgot what I was
How will
going
it be
towards.
important to technology in the future? Like, how will it
Oh yeah.
improve? How will it improve? Not important. How will it improve technology in the future?
Okay, that's right, that's right. Yeah,
Yeah.
so the idea is that, like, um this vector database stuff, it is relatively new. But it's being leveraged by a lot of, like, well, frankly, like, companies that like actually use it. But like for example, right? Like I was like saying, uh, doing simulator search, like something like Spotify. For
Yeah.
like
Yeah.
getting new or getting like similar songs to like what you've been listening to, or
Yeah.
like
Yeah.
even like something like fraud detection. Like, is this case of like potential fraud similar to existing instances of like fraud in the past, or like things like that? Like, the this is it's a very important technology for like for allowing companies to actually solve these complex use cases that you can't just do with like relational, like, or like NoSQL, MongoDB, or like any of the more common databases. So yeah, so because of that, these vector databases are useful for just allowing people to be more flexible in the type of problems they're just trying to solve. that's how I would kind of say that. That's how I would answer your question.
Okay, okay.
Does that make sense?
Yeah, it makes perfect sense, you know. And like as I said, your teacher self always explains stuff very well. Yeah. Uh, so I have one more question. Well, it's kind of a
Absolutely.
two-parter depending on your answer, of course. But before I get into that, I just want to let you know Discord is always your biggest op because why are you on VS Code while you're in the middle of an interview, sir?
Huh? Oh, I, that was that was from beforehand. I forgot to close it. I'm sorry.
Nah, I'm just messing with you. I
I
looked
forgot
up
that was up.
I looked up and like Discord really tells people like everything what you're doing if you have it like configured to it. So I'm like sometimes like it just be like telling people you're doing something and you're just probably not. I don't know. Whatever. But no, for getting into the last question of everything, one thing that somebody told me recently is do work that gets a lot of visibility.
Mm,
And they said don't do anything, no hidden work. So basically like some
mm.
random people come to you, you just do work. It's not very big, people don't really know too much about it, and it's not impacting a lot of people. So she had told me this advice and I actually uh took it to an account. Like a lot of big stuff is what you want to get your name in, people talk about it, it gets more widespread, and it keeps you around longer and things. So
Hmm.
um well, obviously, I would say that this you having an article at this company in somewhat degree is quite visible and big,
Oh
if you would
yeah.
agree so for yourself. So the last question is, do you want to write more articles around like the whole engineering world or things like that, or what you might be working on?
I would love to, like personally, because I mean, I really enjoy like writing like or like just creating like educational content, because I mean, frankly, that is like how I even came to like be programming in general. Like I taught myself like Python,
Yeah,
and like I couldn't have done that with if like other people didn't do stuff like that. And I think it also like makes me way better at like teaching or explaining things by like writing these things. And the side effect is that okay, well, other people get to be happy that they get to learn something that is relevant to them too. And like so I would love like the keep going. Now whether it's like articles like specifically like in the same like Capital One does it. I don't know. I because that was a unique opportunity. So I don't know how often I'll be
yeah,
able to
yeah,
do like that specifically. But like articles or like just content in general, yeah, I would love to. I'm going to be doing my master's at Drexel soon. So I'm like what I'm hoping is that I gain really nice knowledge that like people might not
yeah,
necessarily know about, because like for example like vector databases, like, there isn't like as much content out there. So it's like, there's not like finding things that people might necessarily not know about and then writing something for people to like ease their way in. I like doing that. That's my particular favorite. Um Much more than like writing like research papers and stuff like that. Even though that stuff is extremely useful, obviously.
yeah,
Um, it is often hard for people to just um read a paper. You know what I mean? Like
yeah.
the stuff's pretty dense. So writing articles is usually like the way to go if you're just trying to like spread educational content. You know what I mean?
Okay. And before I get into the next part, I would like
Mm-hmm.
to double down on you were saying like writing an article can help other people of course in the future and things like
Mm-hmm.
that so that they can help learn. for other people, but I feel like it also helps you learn to a degree. Like when we
Mm-hmm.
were talking about writing documentation, when you write documentation, you actually have to learn what you're writing about, and it helps you learn, and it like teaches you time to get more familiar with the topic. So that is another reason why it's so very important. But
Mm-hmm.
now for the $1 million question,
Uh-oh.
the next thing that you do want to write about, what would that be? If you,
Ooh, what a question. Yeah, I'm I'm not sure. I think like the next thing I would like to write about would hmm. I can think of two things. Frankly. I would either I would either like to do something maybe with AWS. I do work heavily with AWS. So maybe the technology surrounding that, or on the on that more academic side, learning taking my time to learn a bit more about like emerging like machine learning models and like AI and making content for that. I know a lot of people do, but I there are times where I think we can serve to be a bit more specific and relate a bit more to real real like uses and provide examples of it. You know what I mean? I'm very heavy on providing like real context for these things.
yeah, yeah,
You know what I mean?
yeah,
I think it's hard to grasp otherwise, you know? Like anything theory, I think it's just really hard to grasp if you aren't like being given like some like real context. You know what I mean? I want all three. I want there to be theory, I want there to be code, I wanted to be
yeah,
useful. You
yeah,
know?
yeah, yeah. That makes a lot of sense, man.
But yeah, that's my goal. We'll
All right.
we'll see what happens.
We shall. Hopefully, it's all another thing that you can come and teach the people about. You know.
Definitely.
Um, but of course, once again, thank you so much for being a guest and joining on here, man. Very appreciate it. You're always welcome.
Absolutely.
If you ever want to come on, you're always welcome. Let you know what I'm talking about the week. We can figure it out. But yeah, appreciate it. And take care and good luck on the whole grad school and your many other success.
Thank you so much. And thank you again for having me. It's great to be on here. Great talking to
Always a pleasure.
you.
All right. And that's basically the interview. That's a wrap for everything. Like always, I hope you guys enjoyed this episode. Don't forget to subscribe, like, comment, and don't forget to share your hot takes. That's something that I really want to get into and start. So, any hot takes in the tech world or any type of engineering and everything, drop them down in the comments. Send them to me. My social medias are in the description, but also my friend's article will be in the description as well too, so you can find it. But greatly appreciate you guys all tuning in. Hope you were able to make it all through. And thank you. Have a good one. See you next week.